Find the radius of convergence for this function. How do we find the radius of convergence? Like what does it converge? Like for what values of x does this kind of series converge? This is adding up the numbers forever. You plug in 1 for n, and then 2 for n, and then etc. 3 for n, all the way, and you're adding them all up. For what values of x? Well, to do this, we're going to use the ratio test. That's what we usually use. And the ratio test says that you take the limit as n goes to infinity of the absolute value of a sub n plus 1 over a sub n. And if it's less than 1, it converges. Whenever that limit is lower than 1, whenever the term ahead is, you're taking the ratio of the next term over the previous term. If that's a ratio lower than 1, that means the next term is getting smaller. So the series converges. So let's do it. So we're going to take the limit as n goes to infinity. Now I'm going to plug in, I'm going to start with a sub n plus 1. So that means I'm just going to plug in n plus 1 for everything over. So there's n plus 1 divided by, and a sub n, which is minus 1 to the n, x to the n over square root of n plus 3. In fact, why don't I just make this a big clear fraction bar? So there we go. So we've got a sub n plus 1 over a sub n. So now what's going to happen? Well, this fraction is going to flip up, right? Because dividing is upside down multiplying. So I'm just going to do that right now. I'm just going to flip it up, save some space here. So it's just going to become square root of n plus 3 over minus 1 to the n, x to the n, right? That's just the upside down. A sub n has been flipped upside down. That's how you divide by it. Okay, can we simplify this? Yeah, we can. So let's bring it down. So the limit n goes to infinity. This is going to be, what is this going to be? So, I forgot the absolute value, didn't I? Yeah, so limit of the absolute value. So really, therefore, we don't care about these guys, right? They just change the sign. Who cares? We're doing the absolute value. So we have x to the n plus 1. In fact, let me stay with the same color. X to the n plus 1. So that's x to the n times x to the 1, right? Because remember, powers add. Remember how that works? So x to the n times x to the 1 is x to the n plus 1. We remember over on the bottom, x to the n, that's this term right here. So sometimes it's nice just to cross these off or circle them as you guys have used him. And then we have right here, what I'm going to do is I'm going to write a big square root, and it's n plus 3 over n plus 4. This and this. So I've used everybody. Still the absolute value. And you want that less than 1. Because that's when it converges, when it's less than 1. Okay, so what's going to happen? This cancels this. And as n goes to infinity of this, remember, it's all about the highest power term on the top and the highest power term on the bottom, because if you're going to infinity, who cares about plus 3 or plus 4? So it's just x, absolute value, less than 1. So therefore, that's just going to be 1. So its absolute value of x is less than 1. That's our answer. That's the radius, what we call the radius of convergence. In other words, what that means is, you might wonder, why do we call that radius? Because if you looked at a number line, you put 0 in the middle, that means x is between, right? X can be anywhere in this zone, right? This is the same thing as saying x is between -1 and +1. Notice the radius means from the middle to the edge. That's what we mean by radius, like radius of a circle. So the radius is 1. The x can be anywhere from the middle, back 1 or forward 1. Anywhere between -1 and +1 is what the absolute value of x less than 1 means, right? Because you can put any number like -zero point .7, right? Like right here, -0.7. Zero point .7. That the absolute value of that would be zero point .7 is less than 1. You can put +0.8, right? Absolute value that's less than 1. Anything between -1 and +1. So the radius of convergence is 1. And so there we go.